Yes, hi everyone. My name is José Luis Millán. I'm coming here today to talk to you about JsSIP, the SIP stack library. Well, I'm currently based in Berlin. I'm working for a company called FRAFOS, where we build a SIP and media server, which is actually an SVC, and it also has WebRTC capabilities. JsSIP is a SIP stack. It's also a Node.js library, even though you can also find Debian packages and Bower packages as well. I have seen before the Debian package maintainer here, David Pocock. And one huge feature for me is that it's fully documented. You can find the documentation in the website.
Can you speak a little bit louder?
Yes, sure, okay. So what's the motivation behind JsSIP? There was a trigger in time, which was the WebSocket transport. When WebSocket transport came to the playground, we saw a huge opportunity to make browsers SIP devices in such a way that these devices should be as not only soft phones, like not hardware would be needed, but so simple to use and to upgrade as reloading websites. So by making a JavaScript library, not only you can have a SIP stack and use SIP in your browser, but you can upgrade to the new version, but by just upgrading the website. You download again the JavaScript file, and you've got the new version of JsSIP. So it was also a nice excuse to learn SIP and JavaScript more deeply, and I really think we were in the right moment at the right place when WebSocket was starting becoming a standard. Looking back, we started in 2011. That's where the development started, and then in that year we could already be able to make a SIP call from browser to browser, or from browser to a legacy UDP or TCP SIP device. Of course, not with media, because WebRTC was not yet already. So we started also writing a draft to make a WebSocket standard transport for SIP. In that same year, WebSocket became a standard, and so everything was clear. I mean, once we were able to have WebSocket as a standard transport for SIP, then the image was perfectly, we could perfectly see that it would be easier once being the standard, the WebSocket protocol. Then current voice over IP servers could adapt and create a new transport in order to be able to communicate these two words, the web and the SIP word. Then 2011, the first SIP call with media, thanks to WebRTC. And in 2014, the SIP over WebSocket became a standard. So there was no excuse anymore for SIP server vendors to implement the transport. There's a list of implemented RFCs. There are many more in the SIP ground, but I think these are no more nor less just those that we needed at that time, and indeed right now. The API, well, there were several points that were quite clear. We wanted to provide an API easy to use that could abstract the user from SIP internals. We were really aware about the fact that users making SIP applications with JsSIP didn't need to be SIP experts. So we wanted to abstract them from the SIP protocol internals. That's why it was a must that the API should be as simple as possible. So it's quite expressive. As you can see, we can create a SIP user agent by passing a basic configuration. which only mandatory options are the SIP URI and a socket, a server socket to connect to. Then we can start the user agent, register and register. How can we call? Okay, just call. How can we send a message? Just call, send a message. Okay. Also, it is a call-driven API, meaning that the communication between the JsSIP objects and the user are the callbacks. So you define your callback functions in order to set your logic. When a new RTC session comes, then you set a new RTC session callback function. You can then in the callback object inspect who is usually the direction is quite a common attribute of JsSIP callback objects, which tells you who is doing this action. Is this new RTC session being locally generated? Is it an outbound call? Is it remotely generated? Is it an inbound call? Then answer, check it, draw, reject, do whatever you need. So, at a glance, this is the JsSIP architecture. I think, yeah, it quite well represents the core. We've got everything. All of these points are stand over the user agent, who holds a transport that holds many sockets. Also, dialogues, who, on top of which RTC sessions are created. You can also do IM message. We have a registrator attached to the user agent, so the user agent can register and register, and this basically is. So as you can see, it looks like a modular design. It was also a must since the beginning. We wanted its element to take care of its things and abstract the others from its internals. As an example, we've got the transport. As we can see in the previous slide, we see a transport and multiple sockets. Okay, then why don't we see WebSockets? Because actually, you don't need to use WebSocket to use JsSIP. We provide a socket interface, which is really simple, which needs to implement 3 methods: connect, disconnect, and send, which will be called by JsSIP when necessary. Also 3 callbacks: on connect, on disconnect, on data. So JsSIP is aware of whether it is able to send data to this transport or not. And it's got some mandatory attributes, well, which got their default values, which are via transport, URL, SIP URI, who helps for some to helps creating the SIP messages and setting certain non-standard values that some SIP server vendors require. This way you can, you are not attached to use WebSocket. Of course, we provide a WebSocket built-in implementation. We also have a WebSocket node module, so you can use JsSIP in Node. Of course, we are talking about signaling, not media. And yeah, that's all. So you could send your SIP messages over HTTP, or over some application over HTTP, or over any other kind of transport that respects this and implements the interface. Another example of this is the communication, internal communication of the objects. We can see here this onion architecture where we abstract objects from others' implementation. So a requester could be I am a message sender, or a dialogue, or a registrar who wants to send, in this case, a SIP message. So it delegates to the request sender, who creates a SIP transaction and delegates the sending of the packet to the transport, who uses the socket, and everyone does its thing. So for example, the request sender, in case there is a need to make a digest authentication, we don't deliver it to the original requester, but we absorb and consume it on the request sender. making this more modular and even cleaner. Another important part is the RTC session. Why is this important? When we are talking about media, we need to look at this class. This is the one that deals with the WebRTC API, the one that adds and removes streams to the WebRTC engine, the one that requests the SDP so it can later send the SDP through a SIP message. And as well, once receiving an SDP, it feeds the WebRTC engine with this information, so we can magically, thanks to WebRTC, establish a media connection. Apart from those actions, these are the typical SIP actions that we could expect from a session, that are hold and hold, mute and mute transfers, DTMS SIP info. We also offer some callbacks, so you can modify your SDP before, when you receive it from the network, before you feed it to the WebRTC core, or after you are sending the SDP to your SIP server. So you can adapt it to some circumstances, or for example, add data channel information or whatever you need. In order to communicate with the WebRTC engine, we use WebRTC adapter, which solves the incompatibility between naming mostly of APIs offered by different browser vendors. This way we just abstract, we just use the standard naming, and we don't care which browser we are talking to. This library solves this issue for us. Okay? Let's go for a demo. Okay, this demo is a double demo. The aim of the first part is showing that we can build a node application in order to use JsSIP for signaling, and the other one will make a media demonstration. Okay. Saúl, please. No, ¿cómo podemos enseñar esto? Y...
Dale aquí, a la pantallita. No, esta no. ¿Dónde tienes? ¿El del monitor? ¿No tienes el del monitor?
No.
Blue screen!
Blue screen of death. ¿Has tirado de él?
Igual lo he quitado.
Show mirroring options. Where are the mirroring options? Hello? Houston.
Okay.
Pero wait, no encuentro cómo cambia cada uno. No quiere jugar. Mueve la pantalla, tío. No sé cómo.
Vale. ¿Cómo la muevo? ¿Cómo que la mueva?
Mueve la pantalla esta.
¿Cómo? ¿Que la mueva?
Tira de ella y mueve la pantalla.
Ah, ok, vale. Okay. Oops. I cannot split. Saul, I cannot split. I needed to split. Well, okay. I will. Okay. Okay. So I will go for the second part of the. Saúl, échame un cable.
Dime.
El browser, tío, no sé cómo. No sé cómo se muestra también.
You want to mirror?
Arrastralo.
Yes.
Yes.
Yeah, what's the command to go for? Okay. Yeah, but didn't show there. I don't know where the fuck they are. Ah, there, mirror display. There you go.
Whew. Okay, sorry for the inconveniences. Okay, I will need to do it in a single. Okay, I wanted to have split it so we could see the execution of the app in one side and the code in the other side, but I will it would have made things a lot easier. So please, if you are interested, pay attention, because they will not happen at the same time. So you can see my cursor. We are requiring JsSIP as well as the Node JsSIP WebSocket, because we are creating a JsSIP user agent using the Node WebSocket transport. So mainly this is in order to show how easy can we use it, this is the main function, which just create a WebSocket, Node WebSocket, creates a user agent with this WebSocket and starts the user agent. There are two callbacks predefined with just the backsum information. The application allows us to be inside this script, so we will be able to control the user agent by executing commands. Okay, first of all, okay. Okay, so I have enabled the SIP login because I thought this was interesting for the first time. Okay, we can see here that the JsSIP is starting, we can see the configuration, and it's auto-registering because by default it's auto-registered. We are registering in a testing service that we have in tryit.jsip.net. Okay, now I will go out, I will disable JsSIP. I just wanted to show you the SIP traffic here. Okay, now we are in the application. I made a very simple CLI where you can kind of control this user agent instance we have already seen, and well, we can see the status. We are using this version, we are connected, registered, and I will establish a remote peer okay, peer. I will connect to my colleague Iñaki. I will try to establish a chat here. Hi there. Hi. Okay, so yep. Okay. Oh, I'm sorry. Okay. Let's call. Yep. Hi there. Hi, how are you doing? Okay, Iñaki is just there. Thanks. Yep. Okay, so let me just tell you what just happened here. We did a kind of trick here. So we were, the chat is based on a SIP message request from one to another, and there was a cookie phrase which is invite plus something, where we send Iñaki a link, a URL to the Tryit JsSIP demo web application, which actually runs on top of the browser. So sending this invitation through a SIP message, and he received this message and opened his browser with the given link. At the same time, I opened as well the browser, so we could make the media communication. And that is it. I'm sorry for the inconveniences on the demo. I hope everyone understood my aim, and I'm willing to answer any question you may have. No questions? Yes?
Do you have suggestions for backends, especially concerning audio codecs between different browsers and different clients, and so they are transcoded on the backend, or what's the normal way to do that?
Well, since there in WebRTC there are mandatory codecs, if you are talking with WebRTC endpoints, you don't need to bother about transcoding because they should share at least a common codec. Okay. Otherwise, if you are trying to communicate with the legacy voice over IP network, then you should take care of that and transcode accordingly. Yes, so it was it.
Thanks, Jose.
Thanks for listening. Gracias.
Tú, que no encontraba el...